Hey guys, welcome back to the channel. So one group of types which you'll use quite often in your programming gets special treatment, and these are called primitive types. Now the reason for the special treatment is that, so when you create an object you use new, right? Now the keyword new. Now if you create an object with new, especially a small simple variable, that isn't very efficient because new places objects on the heap. Now instead of creating the variable by using new, an automatic variable is created that isn't a reference. And that variable holds the value directly and it's placed on the stack. So it's much more efficient. Now I'll make a video about the different places to store data. Just know for now that the stack is an extremely fast and efficient way to allocate storage, much faster than the heap where all the objects live. Now, as you can see here, we have 8 primitive types. The first is Boolean, and it only has the values of true or false. Char is a Unicode character, so that's A, B, C, the $, etc. Then we have byte, short, int, and long, and these are all numbers, all integers. The only thing that differs is their size and the range of values that they can have. And lastly, we have float and double, and these are floating points. So they're decimal numbers, and they also differ by their size and the range of values that they can have. So as you can see here, we have the size column, and Java determines the size of each primitive type. And these sizes don't change from one machine architecture to another as they do in most languages. And because of that, that's one reason Java programs are more portable than programs in most other languages. And now you can also see this default column, and when a primitive data type is a member of a class, it's guaranteed to get a default value if you don't initialize it. And here are the default values for each of the primitive types. So this ensures that member variables of primitive types will always be initialized, and that's something C++ doesn't do, so it reduces a source of bugs. However, this initial value may not be correct or even legal for the program you're writing, so it's always best to explicitly initialize your own variables, and that's considered a good programming practice. However, this guarantee doesn't apply to local variables, and those are the ones that aren't fields of a class. So if you're responsible for assigning your own value before using the variable. If you forget, Java definitely improves on C++. You get a compile time error telling you that the variable might have not been initialized. And right now I'll show you some examples. Okay, so first I'll make a variable, an int variable I, and I won't give it any value. And I'll just add static because I'm accessing it from a static method. Now, because I doesn't have any value, it will get a default value because it's a global variable. In other words, it's a class variable. So if I go in my method and use system.out.println to print the value of I and run it, I'll get 0, which is the default value. However, if I go inside the method and create a local variable, int I, now I'm going to get a mistake here. It's telling me that I have to initialize the variable. So if I run the program, here I get a message, compile error. The local variable I may have not been initialized because we're dealing with the local variable right now. So same goes with all the other primitives. Here, I'll just show you one more example using char C. If I print out this C, I get the default value, which is this square. But if I add the value right here, for example, the letter A, and I run the program, I'll get that value. So I hope you understood everything, and I'll see you in the next video. Bye guys!